What if I told you that the biggest solar storm in 20 years had just hit Earth? We were very lucky. Despite this good news, astronomers are still on alert because the most violent solar cycle in a long time is not over yet. A giant sunspot has formed, similar to the one that caused disaster in the United States 200 years ago. If it continues to grow, things could get tense for us. Either the upcoming storms will bring us the colorful northern lights, or they will paralyze all of our power and communications grids within minutes. Elon Musk expressed his concern. On May 11, 2024, the SpaceX boss released an alarming graph showing the pressure exerted by the latest solar storm on the Muskendamp #039 satellite system. A fierce stream of particles from the sun hit Muskendamp #039 Starlink satellites and increased the measured load and function values. The satellite's defense mechanisms were stretched to the limit, and an even stronger storm could completely overwhelm or even destroy the technology. Of course, that would be a nightmare. Not only would local internet and cellular networks on Earth be down, but it would be a disaster if dozens or hundreds of unwanted satellites were to float around in space. Musk continues to say we got lucky again, but he and his company are worried. The Starlink satellites are among the most advanced in the world, and this is the first real test of the resilience of SpaceX's wonders. Solar flares are considered the most underestimated threat of the century. Experts have long warned of a major storm that would test our entire civilization. Streams of particles from the sun hitting the Earth's magnetic field not only give us the spectacular light shows we normally only see at the poles and call the aurora borealis, but they could also disrupt technology. What many people don't know is that the magnificent northern lights are created by streams of particles from the sun. The charged particles are captured by the Earth's magnetic field and then trapped in magnetic deposits above the poles. In this way, the Earth's magnetic field normally prevents the particles from penetrating deeper into the atmosphere. At the poles, the particles move up and down in the deposited layer until they lose their charge. This is what honeycomb lighting represents. The strongest solar storm to hit us in 20 years has caused the aurora borealis, or polar lights, further south in the northern hemisphere. In the southern hemisphere, people in the far north can see gorgeous colors in the night sky. The northern lights sparkle in green, purple, blue, orange, and sometimes red. If the experts' predictions are to be believed, these particularly powerful storms will persist for some time. Then we will be able to enjoy this colorful spectacle again. Otherwise, we will be in a very delicate situation. The most violent eruptions in 20 years are terrifying to imagine, because the sun can unleash a huge stream of particles at any moment and hit our Earth in 20 or 30 minutes. As soon as the particle bombardment is triggered, it will be upon us. That is the danger of these storms. The time to prepare for a truly violent eruption is very short. Solar currents are triggered by sunspots or coronal mass ejections. Sunspots are temporary regions of the sun's surface that appear darker than their surroundings due to lower temperatures. They are caused by strong magnetic activity within the sun, which inhibits convection. This causes temperatures to drop and extremely powerful forces to form in the affected areas. These can then lead to the release of large amounts of energy at once, ejecting countless particles into space in a matter of seconds. Attention is currently focused on a sunspot cluster called AR 3664, in which 16 smaller sunspots combine to form a large eclipse. By early May 2024, the sunspot will be so large that it will be visible from Earth with the protection of eclipse glasses. The spot is 15 times larger than our planet and is responsible for violent solar storms that have disrupted Elon Musk's satellites. AR 3664 has produced 75 M-type flares and 10 X-type flares in just 1 week. M-type eruptions are of medium amplitude, and X-type eruptions are among the most powerful. On May 3, 2024, an X 1.6 magnitude eruption was observed, followed by several other X-class eruptions, including a violent X 4.5 eruption. These flares are important because they not only release large amounts of particles that can reach Earth within minutes, but they can also cause much larger mass ejections in the solar corona. We are currently in a solar cycle that lasts about 11 years, and we are at our peak solar activity. This 11-year cycle is characterized by extreme and sometimes unpredictable fluctuations in solar activity. During solar maximum, we can expect the most intense X-class flares and the massive storms that experts fear. The current maximum is also worrying scientists because it is happening earlier than expected. So there is something wrong with the Sun, and based on the recent activity of AR 3664, it is even suspected that the Sun and its magnetic field are reversing, which could lead to more frequent and intense geomagnetic storms. The most recent significant solar storm, known as the Halloween storm in 2003, reached G5 intensity and caused global disruptions to power supplies and satellite communications. Auroras were even seen in places like Florida and Mexico. Forecasts for the coming weeks suggest that AR 3664 could cause storms as strong as those in 2003, so we need to be prepared. Currently, this spot is oriented away from Earth and we are safe for a while, but AR 3664 will soon move back towards Earth, which could lead to another season of intense geomagnetic storms. For now, we need to keep a close eye on this group of sunspots to minimize the potential impact on Earth and its technological infrastructure. Sparks flying from telegraph poles in 1859. Imagine looking up at the sky in the morning and it appears to be on fire. This is what Americans experienced around 1859. The Carrington event was the most powerful solar storm ever recorded in modern history. It occurred from August 28 to September 2, 1859, and is named after British astronomer Richard Carrington. On the morning of September 1, 1859, Carrington and his colleague Richard Hudson independently observed an unusually bright white flash on the surface of the Sun. This was probably the first time astronomers had witnessed a solar flare. The solar flare was part of a giant sunspot region that caused intense geomagnetic storm activity. The coronal mass ejection reached Earth in about 17.6 hours. This rapid arrival was due to the enormous speed and energy of the ejection. The effects of these unusual geomagnetic storms were observed around the world. They produced spectacular auroras that were seen in Europe, North America, and even as far away as Cuba and Hawaii. In the southern hemisphere, the northern lights shone as far away as Santiago, Chile, and Queensland, Australia. In the United States, the Carrington incident caused significant disruption to the telegraph infrastructure, the most advanced means of communication at the time. The telegraph system stopped working. Sparks flew from the telegraph wires, and the surrounding area caught fire. The resulting fire and damage to the telegraph system were serious at the time. Many telegraph systems were destroyed by the charge, while others operated completely without additional power. The energy from the solar storm is enough to power some devices. The consequences for the technology of 1859, while huge, are small compared to the risks facing civilization today. If a similar event were to happen today, the consequences for our society, which is completely dependent on technology, would be catastrophic. Satellites, power grids, GPS systems, and communications infrastructure will be severely damaged, and economic losses are estimated to reach trillions of dollars. If such a storm hits us in a very short period of time, malfunctions of control and navigation systems could cause major accidents and disasters, especially in air traffic and aviation. C. Particle jets are both important and extremely dangerous. The Carrington event made it clear that solar storms and coronal mass ejections are actually harmless. They don't harm us humans or destroy anything in nature. And it's just our technology that's at fault. Earth has probably experienced thousands of such violent storms. Solar flares occur almost constantly due to the intense magnetic activity that is completely normal on the surface of the Sun. This activity results in slightly less harmful solar flares and larger coronal mass ejections. A flare appears as a sudden burst of bright energy on the Sun, resulting from the release of magnetic energy into the Sun's atmosphere. This energy consists of bright, high-energy particles and can be released as a small explosion within minutes. Such flares can drift through space for hours. Coronal mass ejections, CMEs, on the other hand, send out large clouds of magnetized plasma. Typically, these ejections are quite slow and reach Earth within hours or days. In 1859, the energy of the CME was so great that the plasma cloud reached Earth in less than 20 minutes. So this was a truly exceptional event, but we can expect such an unusual stream of particles to hit us at any time. This could be worrying. Particle streams may be dangerous for us, but they are actually beneficial. These flows, made up of protons, electrons, and heavy ions, are practically everywhere. They contribute to space weather, carry energy across space, help shape our climate, and the almost constant stream of charged particles emanating from the sun and the outer atmosphere forms the heliosphere, shields us and protects the solar system from interstellar cosmic rays. Without these particles, we would not be protected from the extremely powerful radiation of the universe, and life would not be able to exist. As far as possible, the problem for us is that the flood could disrupt or destroy our technological systems. In today's world, where we rely on satellites, the sun is a huge threat. Experts predict that the flood will hit us again one day.